This unit is all about chemical bonding. So when elements bond together, they actually do so to follow this octet rule. And the octet rule states that elements tend to bond in such a way that each atom has 8 electrons in its valence shell. And remember, a valence shell is a fancy way of saying outer energy level, giving it the same electron configuration as a noble gas. So that group 8, the ones that all have 8 electrons in its outer energy level, those are called the noble gases. And all the rest of the electrons spend their whole lives trying to be like the noble gases. So they can achieve this atomic stability if they follow the octet rule. And in order to talk about bonding, we're also going to use electron dot diagrams. With electron dot diagrams, they only show the electrons in the outer energy level, and they contain the symbol for the element surrounded by dots representing its outer electrons. So for example, before, when we drew lithium, we would draw the nucleus, we would draw the first energy level, we would have 2 electrons, and then we would draw another energy level, and it would have 1 electron. So now, as you can see here, this has 1 electron in its outer energy level, which is what we're representing. We're not worried about all the levels. We're only worried about the ones in the outer energy level. And just as another example, if we look at sodium, it has a 1 electron in its outer energy level. Now take a second and think about it. Do you think it's going to be easier for sodium to give up that 1 electron or to find 7 other electrons? Hopefully you said to give up the 1 electron. And then, when we're talking about sodium chloride, let's look at chlorine. And chlorine has 7 electrons at its outer energy level. So take a second and think about it. Do you think it would be easier for chlorine to find a place for 7 or to just find 1 more? And hopefully you said to find 1 more. So that's actually why sodium chloride forms together, because sodium gives its 1 little electron to chlorine, and then they're both as happy as a noble gas and belong in with these guys. I mean, they don't really move, but they're as happy as those guys. So another thing we need to talk about when talking about bonding is nomenclature. And that's basically the system of naming things, or the rules that you have to follow in order to name things. So for chemistry, the International Union of Pure and Applied Chemistry are the ones that make all the rules. So all the rules we're going to learn today, everything that we talk about, is part of nomenclature and has been decided by the IUPAC. It's kind of like when you're writing, you have to follow the rules of grammar. You have to put periods in certain places, capitalize certain things, put hyphens in certain places, use quotes, all that stuff. Those are all rules that we all follow. With nomenclature, there's rules we follow for writing chemical compounds that have been set by these guys. Okay, so now you need to get out your periodic table, and we need to do a few things to it. First, you need to write these little numbers that I'm about to write on the top of each of these groups. So, group 1 gets a little +1. Group 2 gets a little group 2. We're not going to worry about these guys because those are our transition elements. Group 3 is going to get +3. Group 4 you're going to write share. Group 5 gets -3. Group 6 gets -2. Group 7 gets -1. And you can write 0, or you can draw a crown for the noble gases. That's a horrible crown. I have to do that over again. I'm so sorry. Or you can draw a crown. Okay, that's a little better. Because the noble gases are noble and royalty, so they get a crown. Then you need to look up a Google image search of the metals, nonmetals, and metalloids. So color in or label the metals, the nonmetals, and the metalloids. Now, keep this periodic table with you at all times. It's going to be like your baby for the rest of the year. You can name it, feed it, treat it really nicely. Always bring it with you for tests and quizzes and worksheets, because you're not going to get an extra one. And it will help you. But only write the things that I tell you that you can write on it. So for today, you're writing the little numbers at the top, and you are labeling or coloring in the metals, nonmetals, and metalloids. So there's actually 3 different kinds of bonding. There's also metallic bonding, but we're not going to talk about metallic bonding this year. So instead, we're going to talk about ionic bonds and covalent bonds. So we're going to spend some time first talking about the differences. Ionic bonds are only between metals and nonmetals. And covalent bonds are between nonmetals only. So if I were to give you an element like hydrogen or water, H2O, you would look at the periodic table. You would see that hydrogen is a nonmetal and oxygen is a nonmetal. So therefore, hydrogen would have to be a covalent bond. Also, when ionic bonds form, the electrons are completely given away. And with covalent bonds, electrons are shared. Also with ionic bonds, we figure out how to go from the formula to the name and the name to the formula with the crisscross method. And with covalent bonds, we use prefixes. So this is a formula. If I were to write dihydrogen monoxide, that is the name. So today we're going to use nomenclature and learn how to go from the name to the formula and the formula to the name. And there's different strategies depending on whether you're talking about ionic bonds or covalent bonds. And that is what we're going to learn now. So first we're going to talk about ionic bonds, which means we're going to have a metal and a nonmetal. And we're going to go from the formula to the name. So for example, I may give you Al2S3. So that's the formula. In order to get the name, you're going to have to look at the periodic table. Al is the abbreviation for aluminum. So this brings us to rule number 1. When doing ionic bonds, you don't worry about the numbers. So this 2 right here, I'm not going to worry about that guy at all. Then we look at the periodic table for S, and S is actually sulfur. But that brings us to rule number 2, which is that the second element always ends in IDE. So second element ends in IDE. So we don't say aluminum sulfur. Those sound like 2 separate elements. But if we say aluminum sulfide, now we know we are talking about a compound. So we change that sulfur to sulfide. Okay, the next one. Let's see if we did Li2O. So let's look at the periodic table, and we see that Li stands for lithium, and O stands for oxygen, but we don't write lithium oxygen because that sounds like two separate elements. We write aluminum oxide. All right, and then last example we'll do of the formula to the name for ionic bonds is copper. I told you the answer already. All right, so take a second and try this one on your own. So Cu is copper, like I already gave away, and Cl is chlorine, but since we don't write chlorine, we write chloride. So there, again, we changed all the endings to IDE. So not too bad, right? So now from the name to the formula, so if I was to give you something like barium chloride, first, you would look at the periodic table and you would find barium, which I believe is Ba. And then you find chloride, which is the same thing as chlorine, and that's going to be our Cl. But you need to look at the little number on top of the group that has Ba, and that's going to be +2. And then for chlorine, that's going to be a -1. So now, for the crisscross method, the steps are, you find the little numbers, you cross them over, and you drop the signs. The signs will mean more next year, so just get in the habit of writing them down. So the 2 goes to the Cl, and the 1 goes to the Ba. So when I rewrite this, I'm actually going to write BaCl2. And if you notice, I did not write the little 1 because it's just like in math. If you had x plus y equals 6, you're not going to write 1x plus 1i. No one does that. You just don't need to. So the same way with chemistry. You don't write the little ones. So that's the next rule. What are we on? Rule number 3, I think? Don't write the 1. All right. So let's do another one. Let's try calcium oxide. So if you look for calcium, which I think is Ca, the little number on top is +2. And with oxide, that's the same thing as oxygen, that's going to be O. So that's going to be -2. This brings us to our next rule. The numbers are the same, drop them both. So we're just going to write CaO. All right, and then go ahead and look at calcium fluoride and try doing that one for a second on your own. Calcium is Ca. And the little number we already saw was 2. And then fluoride is the same thing as fluorine, so that's F. And that is a -1. So you're going to get, if they cross over, you're going to get CaF2. So as we mentioned, for covalent bonds, we don't use the crisscross method. We use prefixes. So one thing that you can write on the back of your periodic table is that for 1, that's mono. 2 is di, 3 is tri, 4 is tetra, 5 is penta, Duh. 6 is hexa. 7 is hep. Duh. 8 is octa. 9 is nona. And 10 is deca. So that you may write down on the back of your periodic table. I don't expect you to necessarily memorize that. You may start to know it because you use it so much, but you don't have to memorize it. All right, so when we go from the formula to the name, if you are given a covalent formula such as CCl3, then we look at the periodic table, and for example, C is carbon. Now, this really does have a little 1 there, but the next rule, I think, is 5. The first element doesn't get the mono. So it should be monocarbon, but since carbon's the first element, we're not going to write it. And then Cl is chlorine, and that's 3. So it's trichloride. Notice that the little 3, the subscript, is after the Cl, but when we write out the name, the tri goes in front of it. Let's do another one so you see. Let's try NH3. So N is for nitrogen, H is hydrogen, so the 2 is di. So you write dihydrogen. All right, and then something like water. The di, since it's not 1, does now get put with the first element. So you would do dihydrogen monoxide. If you have similar sounding vowels next to each other, then you drop one of them. Like you don't say monoxide, you say monoxide. So let's try one more for you guys to do for a second on your own. All right, try that one for a moment. I'll give you a second. So the answer is xenon tetrafluoride. With covalent bonds from the name to the formula, now you may have something like, let me go back to one of my examples. Dinitrogen pentasulfide. So we see that here we have a prefix and here we have a prefix. So di is 2, so we have our nitrogen with a little 2, and penta is 5, so it's sulfide, S5. So that's what you write for your answer. Let's try another one. How about carbon tetrachloride? So carbon is C, there's no mono there, so we don't have to write the 1. And then tetra is 4, so Cl4. All right, I'll let you guys try one on your own. Try carbon monoxide. Yeah, CO, carbon monoxide. All right, there's a bunch of little rules you need to know, but once you know them, this is super easy and, dare I say, even sometimes fun You're now ready for the worksheet on the HyperDocs, so go ahead and open that. And I believe on the directions it says that you can work with one other person. So once you and the person you're going to work with have completed this, then you can sit together and work on the worksheet. Any questions, let me know.